Climate change is a hot topic, but researchers study the coldest regions on Earth to track changes that may eventually happen everywhere on the planet. Two key indicators for scientists are ice and snow conditions.
The fact that it's a very good reflector plays a very important role in our weather and climate.
Martin Jeffries is a researcher at the University of Alaska Fairbanks Geophysical Institute. One of his projects surveys the thickness of the state's lake ice and snow. But Alaska covers as much area as Texas, California, and Montana combined. Jeffries needed help. His new assistants are from Alaska's elementary, middle, and high schools. The University of Alaska's Geophysical Institute has helped dozens of schools set up their own ice and snow laboratories as a part of ALISON, the Alaska Lake Ice and Snow Observatory Network.
And they go through the basic ALISON procedures and go back into the classroom, and they calculate temperature gradients, and they calculate the snow density and the thermal conductivity, and from that they calculate how much heat is being transferred from the bottom of the snow to the top of the snow.
Because lakes are basically storehouses for heat, differences observed over many winters can indicate climate change. In the summer, lakes soak up solar energy and water gets warm. Then in the fall, the process works in reverse. Air temperatures drop and the lake water releases its heat. When enough heat rises from the water freezes, creating lake ice. The transfer of heat process is a concept teachers present in classrooms from elementary school all the way through high school physics. ALISON was a natural collaboration for scientists and students.
When the students and teachers go out and they make their measurements at their ALISON study sites, they go back to the classroom and they enter their data into the computer, and the data come back to us. And we do quality assurance and control, and we put the data on the ALISON website, so there's access to everybody within the network.
The students are genuine research assistants and get valuable experience from ALISON. But it's also a hit with teachers. It offers a means to create a working laboratory and to show real-life applications for classroom lessons.
The kids, they learn how to do field data and crunch numbers and make graphs. They learn how to measure snow and how to calculate density, and they learn about thermal conductivity. So they're learning a lot. One of the students is a senior in high school right now and is going to go on to study physics, and I'm hoping that part of it was what she learned out on the ice. $27.5. 27.5.
Negative 4.8.
Excellent. Very good. And then we'll just leave the probe in for the next. If you sat anybody down and they thought about it for a moment, everybody could come up with at least one teacher, whether it's in primary school, secondary school, or university, that's made a difference. If we're honest about it, our teachers do make a difference, and we owe so much to them.
Finding answers often requires teamwork and partnerships. Getting students involved in climate research in Alaska is building both, as well as inspiring a new generation to discover a future in science.